All right, this is the big one, folks. Temperature control, and this is one that obviously this is why we use these devices, because they control by temperature, and just as a quick breakdown, I don't want to get too deep into this because you guys should know this if you're watching this video, but we use a non-resistance or a low resistance wire. Nickel specifically because it has a temperature coefficient of resistance that is pretty linear. So temperature rises, resistance rises, and the processor in this can use that to interpret that into a temperature. So what did I do? Now I used a temperature probe and plugged it into my Fluke multimeter. All right. Now that being said, that is not how Evolve calibrates these things. Evolve uses this is to my understanding, based on what I watched Phil Basardo do. Thumbs up, Phil. You get a thumbs up because you're a clicky button. You, sir, are the embodiment of a clicky button. So you get a thumbs up. Anyway, so the way they calibrate their coils is, and this is not a nickel build, by the way. You can this is one of my Canthal builds. I'm just showing you how I did it. But they use a FLIR camera, an infrared. Thermal infrared camera, and I don't have one, and I'm not going to buy one. I am, however, a certified I'm an IR thermographer. I'm certified by FLIR to use the cameras, and I understand how they work. And I saw Phil had to go through quite a learning curve to learn it, and I'm glad he did, because you can't just grab those cameras and use them. There's a lot of settings you have to go through. So instead of spending a couple grand on a camera and doing all that, I'm just going to do it this way, and understand that I did it the same way on the DNA40 that I did on the SX350, and I got the readings that I got. So just understand that even though this is not the ideal way to do it, it is a valid way to do it. This thing still picks up temperature. Bottom line, this thing detects the temperature of the item that it is close to or contact with. So let's not lose perspective. Okay. So basically I jabbed the temperature probe into the wick. Right in the center, I made sure it wasn't touching the coils, and I fired it up. And so when I had the wick in, what I did was I said I used a 10-second hit starting at a 200-degree reading, and wanted to see where it would take it. And this is all done at 40 watts or 40 joules. 40 watts in the DNA40 is the same thing as 40 joules on the SX350, by the way. How do I know that? Because if the SX350 fires at a constant 40 joules every second, joules per second is a watt, so that's 40 watts. Understanding science is a great thing, isn't it, kids? So, same setting. And what I found was a 10-second hit from 200 degrees Fahrenheit was sufficient to get it to start hitting temperature control mode. So it gave me an idea of what temperature on the Fluke it was at when it started hitting temperature control mode. And that worked out pretty well up until the very high settings. Oh, and by the way, the DNA40 has just a slightly wider range of temperatures than the SX350. So I restricted it to 300 degrees Fahrenheit up to 500 degrees Fahrenheit. Those were my my left and right limits. So the long and short of it is two takeaways. The SX350 for the most part overshot the temperature setting when it hit temperature control. Only until it got over 400 degrees did it start did it stop that with this testing method. So the DNA40, on the other hand, was closer, but it was under. On the lower settings, it was actually very close. Like 300 degrees and 350 degrees, it was actually pretty close. Whereas, and on the SX350, it was actually almost as close. But when you hit, but above 350, it was trailing behind by a bit. And whereas the SX350 was overshooting by a bit. And so I can't really give one or the other a win or a lose there. And the thing about it is, if I kept going, and I'm gonna talk about this with the second type of testing I did. But if you keep going, if you go until timeout on the regulator, and you go again until timeout on the regulator, and you go again, the temperature of the coil or the wick just keeps rising. Ultimately, because neither regulator completely shuts down, it always adds at least a little bit of heat or a little bit of energy to it. You will actually, and I did some other tests where I did that, and it just goes almost off the charts. You can make it go up to 900 degrees if you just keep hitting the thing. So understand that the temperature control is really within the parameters of vaping, which is take a few seconds of a hit, blow it, and then wait, and then do it again. So it does control temperature, but not completely, not absolutely. And that's important, because this is not a PID controller where it will absolutely control the temperature by using a true temperature feedback. It uses an electrical reference and assumes a temperature based on it. So they're imperfect systems, but they do good enough, we'll say. So that was a wash to me. It was also an arbitrary test, just something I came up with to compare them. Really, and I used this with the MX2 and the Foghorn, and they both came out about the same. On the MX2, the DNA was a little low. The SX350 was a little high, like I said. On the Foghorn, the DNA was started out actually a little high, and then was actually a little low as it went up in the settings. And same thing with the SX. It was a little low. Actually, the other way around. It was actually a little low. Well, no, it was a little high. Sorry, it was a little high, and then it started getting a little low. And basically, it was meeting the limits of their abilities. So once again, it's a draw. Now the other test I did is basically the same concept. Just where's my MX? So same method of reading the temperature, but I took the wick out and did it with a dry coil, and unplug my charging setup here. Okay. So I lined this thing up just right to get in here and to sit without touching the coils. Let me tell you how much fun it was to get that thing lined up just right. So I got it in there, and so we're measuring the temperature of the air right inside of the coil. And once again, this is not how they calibrated this device. They calibrated it with a coil in, looking at it with a FLIR. So understand that this is far from ideal, but I just wanted to see. I wanted to see what it would do. And even if I had the IR camera, and you can go look at Phil Basardo's review, and you'll see the same thing. If you don't have the same setup that Evolve did, you won't get the same results. And if you don't have, so that's the thing, is these things are based on certain conditions, and it has certain limitations. So if you don't like it, you can suck it. So let's look at the results of the dry coil setup. So what I did is, once again, arbitrary limits. I said 150 degrees Fahrenheit to a cutoff, actually to 2 cutoffs. So I ran it till the regular cutoff, then I went right back and ran it again until it cut off. And again, I got kind of the same results as I did with the wick test. The DNA40 ran a little low, and all the way through. And the SX350 ran a little high, and then almost immediately went a little low. So not quite the same readings. They were both on the low side as far as the dry coil went, and which is to be expected to some extent, because we don't have the heat transfer. Air doesn't transfer heat as well as that liquid. Once you get that liquid hot, there's more thermal mass, but once you get it hot, it's going to transfer heat a little more quickly. So whereas the air is going to dissipate it, you're not going to get that transfer through the air. Anyway, so the bottom line, once again, these were real close. Technically, the repeatability on these, some, I did it a couple of times. I'm going to post up one example of each once I publish this, and you'll see that they're about the same. Sometimes the SX350 was technically closer to the set point. Sometimes the DNA40 was technically closer to the set point. But it's too close to call for me. So, bottom line, sorry if you're disappointed, but temperature regulation is about the same on these. They're not strikingly different. So DNA40 fans and SX350 fans both, you're going to have to deal with the fact that both these companies make pretty well acceptable products.